Hi, good afternoon. Welcome back. Let's go ahead and knock out today's lecture. Between yesterday and today, you will need to leave a blank page for that KWL. So here was the previous lecture, all about those triangle angle theorems. So that was lesson 4.2. Leave yourself a KWL page for chapter 4, lesson 2. That assignment was out by the calculators yesterday. You got a chance to work on them yesterday. If you haven't finished, you'll want to finish it sometime today, early tomorrow, and get that in as soon as possible. If you already finished it, don't worry about it. You're in good shape. Today's lesson is chapter 4, lesson 3. We're going to be starting on congruent triangles. Today is the 3rd of December. We're going to be using properties of congruent triangles in order to say things about other triangles and their parts. And in order to do that, we've got to be able to identify the different sides of the triangles, the different angles in their triangles, as well as be up on our definition of the word congruent. Let's take a moment and adjust my notebook here. Oh, there we go. All right. Looks green.
Big screen.
Oh, big screen. Yes, I'll be moving the big. Do you mind, guys, if you don't scoot the thing other way? Perfect. Yes, lovely. I will full screen it in just a few moments. Give everyone a chance to make sure that they got the objectives. Before we start talking about congruent triangles, however, I have got to take a moment and define a word that I think is familiar to most of you. Yeah, polygon. Well, let's do plural. Polygon. Just one polygon right now. What does polygon mean?
More than one side. More than
three sides closed figure or something.
Three-side closed figure. Something has sides and stuff. Yeah. Okay, so I'm going to be more specific with the definition, but in a way that allows us to broaden it to handle like a lot of different figures. Okay. So a polygon is going to be any closed figure. And this closed figure just needs to be made up of straight sides. We don't care how many sides there are. We don't care what their sizes are. We just care that they're straight. Okay. Pull out the bad artist in you. Ready? All right. We're going to draw just a spiky shape. All right. Polygon, yes or no?
yes.
You're right. Why?
Because it's closed and has straight sides.
Perfect. That's it. You're right. It's a polygon. Good job. All right. Bad artist. Ready?
No.
Why not?
Closed.
Yeah, not closed. All right. Bad artist time.
No.
Why not?
That's straight.
It's not straight. We got a weird curvy thing. It kind of does. It's a very, very bad artist moment, right? All right. So we can now identify what polygons are fairly easy. And we'll get more in depth with polygons as we go. We just want to do a brief introduction to them. But this sets us up to be able to talk about congruent ones. Okay, we know what a polygon is. Closed figure, straight sides. And we know what the word congruent means. So we've got to figure out what it means when we mash these two words together for congruent polygons. Okay. Congruent polygons happen when all of the different parts of one polygon I can't write today. I think I misspelled polygon, I'm sorry. Are congruent to the corresponding parts of another polygon. Let's see if I can spell it right this time. Polygon. Yep, my spelling. All right. So far, so good? All right, let's draw a picture, and we'll put some markings in there to try to make this make more sense, and then I'll give you the proper definition of what it means for it to be congruent polygons. All right, so draw some triangles, because those are kind of the easiest ones for us to deal with. And don't worry about whether they look congruent or not. We're going to put markings to make them that way. And this is the time for us to bust out the colors. Okay, so if you're following along with color, label this vertex A in one color, and this vertex over here H in another color.
Is that red?
Yeah, I used red. Oh, same color as before. I'm sorry. I'm sorry. Same color. They're both the same color. They're both red. Sorry. I need to put something other than water in my coffee cup, apparently. I need coffee. I guess. All right. In a different color, you're going to mark this one as B, and let's mark this one as J. And use the same color as the one for B. And then in a different color, let's mark this one as C, and in that same color, this one is K. All right, so far so good. All right, so in order to sit there and be like, okay, these are congruent polygons, they don't look it, but we're going to make them that way. What you have to imagine is that you can do any kind of transformation you want to this one, ABC. You can slide it around, you can spin it all over the place, and you can flip it any way you want. Translation, rotation, reflection. And when you do that, when you get this to land on the other triangle, you match up the color. This vertex goes on this vertex. This one ends up on this one. And this other one ends up on this other one. And they don't look the same because I drew them stupid. But if they were the same, you could do that and it would land right on top of it and there wouldn't be any difference. It would be the exact same thing. Okay? So assuming these things are, we can mark our congruent angles. I'm going to make with the color again. Angle A we'll say is congruent to angle H. And we're going to mark that with a single line through that angle. So here's angle A, and here's angle H. And you saw that in yesterday's worksheet when you had some angles that were congruent to each other. They had that one little marking. Angle B is congruent to angle J, and we're going to mark that with two lines through the angle. It looks something like this. You don't have to extend them beyond the sides of the triangle. You can keep them all neat and tidy within it. You'll see the worksheets and test questions and things that I give you will keep it super tidy. I'm kind of messy and I like them to stick out. So you do what feels comfortable for you on that. Then we can say that this angle C is congruent to angle K. And I'm going to use 3 lines in the angle to show that. 2, 3. 1, 2, 3. There we go. We have our angles being congruent to each other. So far, so good. No confusions, right? We're okay? All right, let's do the sides. So let's mark out the congruent sides. And again, we're being very careful to mark the ones that correspond, that should these be congruent, they don't look it, but if they were, we could spin the triangle, slide the triangle, or flip the triangle so it lands on the other one, and all those corners match up, and all those sides match up. Okay? Between point A and C, we have segment AC. And that segment is going to be congruent to the segment that corresponds to it in the other triangle. HK. Now, please note that with line segments, it doesn't matter what order you write the name. AC is the same as CA. HK is the same as KH. So I could have said AC is congruent to KH and it would have been the same thing, but when we get down to writing that the shapes are congruent, the order in which you write the letters becomes super important. Okay? So I want you to go ahead and make that a habit right now when you're writing things are congruent from one shape to another. That if you know that they match up in some way, that you try to maintain that order. Just so that when you get to the very end and you're writing the name of the entire figure, it's easier to handle. Make sense? Okay. I'm going to mark these with one line. I do not, I'm sorry. We have line segment C, whoops, gotta get my colors, CB, and that is going to be congruent to line segments KJ. Now I'm going to mark this one with two lines. And then our final segment. Oh, thank you. Oh. Our final side is found between vertices B and A, and it will be congruent to the side in the other triangle between the corresponding vertices J and H. I will mark these guys with 3 lines. Now the colors I grabbed here really didn't matter. You don't have to match to mine. I just wanted them a little different to make it easier to see. Okay. So now we have our triangles marked like this, and we can say that they're congruent. So we have our congruence statement that can be written. Congruence statement should be written this way. A, B, C is congruent to triangle H, J, K. The vertices are all in the same order with the ones that correspond with each other. You should not write your congruence statements this way. Triangle ABC is congruent to triangle HKJ. You see what's wrong with that second one? Yeah, they're out of order. You went the wrong way. So when you're writing the congruent statements for congruent polygons, be really careful with that order of those corresponding vertices. Okay? You don't have to write the non-example if you feel that it's going to confuse you, but I wanted the non-example in here so that you could at least see it and be aware of the mistake that could happen. This leads us to the proper word definition for congruent polygons. So definition of congruent polygons. It says this. two polygons are congruent if and only if, and I'm going to underline that phrase because it's important, their corresponding parts are congruent. And that's literally what we just spent the last, I don't know, 5 minutes discussing and drawing. Is that working out?
Yeah,
Okay.
corresponding.
Their corresponding parts are congruent. All right, I underlined that phrase if and only if because it makes this thing able to be said as a conditional if-then statement and a two-way street. You can say it normally and its converse, and you're saying like the exact same thing. Doesn't change. Okay? So I could say this thing as if two polygons are congruent, then their corresponding parts are congruent. I could also say it as if their corresponding parts are congruent, then two polygons are congruent. That if and only if allows you to go back and forth that way and still have everything be okay. All right? Now this definition leads us to the very last thing for this part of today's lecture, which is this. It's not a word. It stands for this. Corresponding parts of congruent triangles are congruent. It's basically this definition of congruent polygons, but really specific to triangles. If you know triangles are congruent, then you can say different parts of them are congruent. And as we move along through the various proofs that you're going to be working with, this one might be something that could be very powerful and very useful to you. If you have triangles that you know are congruent, you're trying to show different pieces of things are congruent. Okay? So hang on to this in your arsenal. It's a good weapon. We're doing great on time. We're at about the 18-minute mark, so we're a little bit shy of the 20 for this lesson portion. You have opted to go in and do tomorrow's lecture portion. It's the same lesson, it's just the second half of it. So I'm going to wait a couple more seconds because people are still writing down the very last one. If you are done writing, next page, or if you have room, continue. We'll go right on. The next part of the lecture has three big portions. We have a theorem, we have some properties to remind you of, and then I'm going to walk you through another proof example so that way you've got some more things that you can use on your upcoming proofs.
On this one, quick question.
Yes.
What time about reading deals?
Real quick. Shouldn't take long at all. Because it's just recruit. And they didn't announce it, so.
They didn't?
Yeah, the announcements didn't go off today.
Oh, you did it?
No, they didn't. They didn't. I was very sad. I was very sad. Nothing. Nothing. There was no announcements today. Huh?
They might
No.
play it after school.
I don't know. We'll see. All right, here we go. Here's our theorem for the day. Our theorem for the day is called the third angles theorem. It's an if-then statement, and it says this. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So if you're staring at a setup, you've got two triangles. You've got two angles in those triangles congruent to each other. Then the third angle of the triangles are congruent to each other as well. We're going to use this in just a minute with the proof that we're going to do. You are going to be required to prove that this theorem is true. Let's do an example with some numbers so you can see how this theorem works. And maybe it'll spark a, oh, I think I know how this one could be proved. So if you have that moment somewhere, jot it down real quick to the side so that you have it. We need two triangles. So please take a moment, pull out your bad artist hat, draw two triangles. They don't need to look congruent. And I also need, when you're ready, 6 points to name these three triangles, and I would like it from 6 different people, please. Thank you. Go.
Oh. Hey.
You.
Oh.
C.
We have C. R.
B.
Oh.
B.
Because there's already C.
Oh, she already put it.
C.
She was saying she really wanted that. Look, I used the letter, okay? I used it.
That's what she used.
I used it.
No, because I said C that. She said it the same time, so I was like, oh, okay, she's here. But then I said it again, she said it the same time, I was like, okay. And then I was like, I thought you didn't.
Yeah, I got it. I heard you. I heard it. It was stereo. All right. Let's get some numbers and some congruent markers in there. Let's make C 30 degrees and make R congruent to C. Let's make A be 70 degrees and let's make it congruent to Q. And then we're going to be asked to find the measure of angle J.
Oh, and
No, just J. This. The third angle theorem is set up for us here, isn't it? We got two triangles. They have two angles that are congruent to each other, yes? Yeah, this one's congruent to this, and this one's congruent to this. Two triangles, two angles congruent to each other.
80.
Which means that this angle here must be the same as this angle. So if I can figure out what the measure of angle L is, it automatically gives me J.
80.
How is it 80?
you
Add 30 times 3 minus 180.
Yep. Add the two you know. Subtract that mess from 180 because we are in Euclidean space. I promise you we would not do calculations in any of the others because those calculations are weird. And you're done. I'm going to give you a couple of seconds to stare at this example and be like, how could I use this, leverage this on my proof?
I don't think that will.
Jot down whatever you have in your brain right now, somewhere on the edges of your setup here. It's okay. It's okay. You're not expert proofwriters yet. I know this. I'm not expecting you to be. It's okay. But if you saw something, I wanted you to have a few moments to jot it down if you saw something that you thought could be useful. All right, let's move on to the properties.
Do we have to proof rate?
Huh?
Do we have to proof rate?
Proof rate?
Proof rate. Yeah, I would agree with that.
For the third angles theorem, yes, you will have to write a proof for the third angles theorem. Okay, we're going to go over the properties of congruence. There's only 3 of them, so this is going to have 3 subheadings. You've seen them before in algebra. Now we're just going to formally write them out for congruence, okay? The first one that we have is called the reflexive property. When you're writing your formal proofs, you'll have to write reflexive property of congruence because it's different from the one of equality. but for this notes I'm not going to because it's taken care of over here on the left. The reflexive property of congruence says this: if I have any shape, which right now I'm going to call triangle ABC, it is congruent to itself. Duh, right? You're having that moment of, well, of course it's congruent to itself. But in formal proof writing, you can't say it's congruent to itself because it is. Like, that doesn't work. So you have to have this kind of formal name for it, the reason why. And this is the formal name for that, because it is. Okay. The second one is the symmetric property. Again, also of congruence. Please know that these properties of congruence will work for anything that's congruent, regardless of the shape or the item that you're talking about. But we are going to see them in an example of triangles. Symmetric property is an if-then statement. So your setup is if you have some shape, which right now we're going to call triangle ABC, and it's congruent to some other shape that we're going to call triangle EFG, then we're allowed to say that that other triangle we have, EFG, is congruent to the first shape that we had, which we called triangle ABC. Yeah, again, it's another duh. But again, in proof writing, we can't use the duh as a reason, so we have to give it a proper name. And this proper name is symmetric. They are challenging. They're challenging. I agree.
This is my 2 weeks in cursive P.
I just kept him to a work class with, I told him I had to go on proofs, he's like, oh, let me see it. And he looked and he's like, we're going on proofs for a whole 6 weeks, I don't know what this is. And I was like,
Miss, because their proofs, he fills them all out for them except 2 blanks they have to fill out.
Yeah, no, I'm not going to water it down. You guys are going to be able to do the whole thing. At the end, I don't expect you to be able to do it right now. The end of the year, yes. I will expect you to be able to make a proof by yourself at the end of the year. Right now, no. You're figuring it out still. Okay?
I can do it.
All right. Here's the last property. It's the transitive property. Oh, you're like, oh, I know this one. You know it for algebra. You've got 3 things. 2 of them are equal to each other, and that one of those is equal to something else, and you can use that as a bridge. You can do it also here with congruence. So if I have some shape, which right now is going to be a triangle named ABC, and if I say, hey, that shape is congruent to this other triangle over here that I'm going to call EFG, and that triangle EFG is congruent to some other triangle way off in the other part of the world, JKL, then I'm allowed to use this triangle EFG as a bridge to connect the first shape I started with, triangle ABC, with the final shape I'm looking at, which is JKL. Right? Okay. If you have half a page or more left, you can continue. If you don't, the proof might be a little too big, not because there's a lot to write, but because I want to give you room to do the messy mind map thing, okay? And to write big and to scribble. But if you feel that you can make it small, you might be able to do it with maybe a third of a page or so, then go ahead.
Wait till if you don't have room to read it.
Next page. All right, here we go. All right, this is going to be an example. And all we're going to do in this example is we are going to write a proof. That's it. That's all we're doing. We're writing a proof. All right, I need you to bear with me through the given and through the proof statement because I am just going to write what is going to look like just a bunch of letters and randomness. And then I'll draw the figure and it'll make way more sense, okay? So just bear with me. Follow along. It'll make sense in a moment. Okay. Given line segment DE congruent to line segment GE, line segment DF congruent to line segment GF, angle D congruent to angle G, and angle DFE congruent to angle GFE, we want to prove that I have two triangles, one named DEF, the other named GEF, and they are congruent.
Mm.
Right.
That requires a lot of thinking.
Here's the shape, the figure that I'd like for you to draw. It doesn't have to be pretty or neat. They're two triangles stuck together at one side. They don't even have to look congruent to each other, because with a proof, it doesn't matter what the picture looks like. As long as your logic is sound and your proof is strong, it doesn't matter what they look like, they're congruent. All right. So let's start off this proof by marking down what we already have. I have a line segment DE congruent to GE. So I'm going to use one little line through that side to mark that they're congruent to each other. I'm going to look at the next one. I'm going to use two lines because these are also segments. DF and GF. Now I'm going to work with the angles. One line for my first pair of angles, D and G, and two lines for my next set of angles. Now this first angle says D, F, E, and so it's this one right here. My vertex is always in the middle. So I'm going from D toward F, and F I'm making a turn and I'm going toward E. So this is my angle right here. The next angle starts at G, goes toward F, and up toward E, so that other angle is right here. That's all I know. That's all I've been given. I'm allowed to use any theorems that have come before this. Third angle theorem you're allowed to use. Okay, it's been proven, you're allowed to use it, but you're going to have to go and prove it too so that you can work through that mindset. But you can use it without needing to prove it. Okay? So you can use any theorem, any definition, or any property to try to get there. And your goal is to try to get to the point where you say that two triangles are congruent. This is our goal. Okay? We want to get to here. Well, what could we use to get to there? Well, to say two polygons are congruent, we need to say that all their corresponding parts are congruent, right? Yeah, that's our definition of congruent polygons, isn't it? I'm abbreviating. Remember, this is scratch notes. On the formal proof, don't abbreviate, write everything out. But on our scratch notes, just throw it down however. So if I can get my definition set up, if I can get all my polygons to show that all their corresponding angles and sides are all congruent to each other, then I can say that they're congruent because the definition will let me. So let's look at my figure and see how far away I am for that. I have these two angles and these two angles. I'm really just missing that angle and that angle. So I really need to be able to say that the angle that goes from D through E toward F is congruent to the angle that goes from G through E toward F. The big question is, what do I have in my toolbox that allows me to say that with this setup? I've got two triangles and two sets. Writing what? Yes. I have two triangles and they have two angles that are congruent to each other. What's that the setup for? Got two triangles and they have two angles congruent to each other. The third angle theorem. Third angle theorem says if two angles of one triangle are congruent to two angles of another triangle, that's what I've got. So my reason for being able to write this is the third angles theorem. And again, abbreviating really bad here because this is just the mind map. This is just the rough draft. Doesn't have to make sense to anyone but you. All right, what's the last thing that's missing? I have, whoops, I hit my notebook, I'm sorry. I have this side congruent to this side, and this side congruent to this side.
E and F.
Yeah, I'm missing this side of DEF congruent to this side of GEF. I basically need to figure out a way to be able to say that line segment EF is congruent to line segment E. To itself. I need to be able to say it's congruent to itself.
Reflexive property.
The reflexive property. All right. Now that we have all of the angles congruent because we got that third one and all the sides congruent because we've got that third one, that gets me to my definition and my theorem is proved. The hard part is done. Now we just have to make it look pretty. And we can do that in the next 4 minutes.
You have only 4 minutes?
Until for the 40-minute mark that I was planning for, yes.
Can you, do
Oh, right there? Is that good? Okay. When you're writing a... Yeah? Yes, yes, yes? Okay. When you're writing a two-column proof, always start with the given. Always, always, always. And then here's the part where unless you're a trained professional in writing while saying something completely different from what you were writing, I recommend that you, with proofs, you don't talk about something different than what you're writing. Because you really have to make sure that you're writing all of your letters and all of your symbols in the correct order, or bad things happen. Oh goodness, I'm out of space. And that you make sure that you don't run out of space. That's the given line. Just go up to the given and copy the given. Just copy. I'm going to take my light blue pen and I'm going to put a little squiggly line here just so that it's a little easier to see that I'm done with that one statement and I'm going to another line because I have lines on my notebook paper and I don't want it to be confusing, okay? All right, second statement. The next challenging part in writing a two-column proof is going from this mess up here to something neat. And really right now it's what should I write first? The short answer is the thing that affects others. Does saying that the angles are congruent to each other in any way affect that the segments are congruent to each other? No. And vice versa. So the order doesn't matter. Pick one. Which one do you want to write first?
Third angle.
The reflexive property one, you want to write the angle one. So you write the angle one, we'll write the segment one, and everyone will be happy. So I'm writing the segment one, she's writing the angle one. We're writing the reason. Those of you who are writing the angle, the segment one, please write reflexive property of congruence. If you're writing the angle one, you need to write third angles theorem all out in words. Don't abbreviate. Again, I'm going to take my light blue pen and put a squiggly line, just so I know that that line of my proof is done. The next one is going to be the other one that you didn't write. So if you wrote the segments with me, you're going to write the angles with me. If you wrote the angles with her, you're going to write now the segments with her. Again, find your reason and write it all out in words, no abbreviations, spelled properly.
So you should write out the numbers?
Yeah, so third angles theorem is properly written out, the word third, not the number 3 RD. Yeah, yeah, I messed up. It's a singular theorem.
Oh, man.
Yeah, I'm sorry. Look, trained professional talking about something different than what you're writing, I still mess up. Which then allows me to say that those triangles are congruent, and so all I have to do is just write that they're congruent, and I have my reason right up here, definition of congruent polygons. And so that's what I write. Again, do not abbreviate, so you write out the whole word definition. Please don't use the little symbol for congruent. You have to write out the word. And since we have now written as a statement the line that was given to us at the beginning as prove, we have proved the theorem. We